A piece of rubber 10 cm long stretches 6 mm when a load of 10 Newton is hung from it. What is the strain? Solution. Tensile strain is equals to extension E over original length L, which is equals to E over L, which is equals to 0.006 m all over 0.10 m, which gives us 6 times 10 raised to the power minus 2. Example 5. A string of force constant 1500 Newton per meter is acted upon by a constant force of 75 Newton. Calculate the potential energy stored in the string. Solution. Force F applied is equal to 75 Newton. Stiffness K of the spring is equal to 1500 Newton per meter. From Hooke's law, F is equal to Ka. Therefore, 75 is equal to 1500 times E. E is equal to 75 over 1500, which is equal to 0.05 meters. Energy stored PE is equal to half FE, which is equal to half times 75 times 0.05, which is equal to 1.9 joules. Example 6. What force must be applied to a steel wire 6 meter long and 1.6 meter diameter to produce an extension of 1 millimeter? Young's modulus for steel is equal to 2 times 10 raised to the power 11 Newton per meter squared. Given length is equal to 6 meter, phi equals to 1.6 millimeter, which is equal to 1.6 times 10 raised to the power minus 3 meter. A equals to 1 millimeter, which is equals to 1 times 10 raised to the power minus 3 millimeter. Capital E is equals to 2 times 10 raised to the power 11. We are asked to find capital F. Solution. F over A times I over E is equals to E. F is equals to EAE all over I. A is equals to pi r squared, which is equals to pi d squared over 4. F is equals to 2 times 10 raised to the power 11 times pi times 1.6 squared times 10 raised to the power minus 3 times 10 raised to the power 3 all over 4 times 6. F is equals to pi times 1.6 squared times 10 raised to the power 5 all over 12, which is equals to 67,029 Newton, or which is equals to 6.7 kilo Newton. Example 7. A force of 20 Newton is applied to the end of a wire 4 meter long and produces an extension of 0.24 millimeter. If the diameter is 2 millimeter, calculate A, the stresses on the wire, B, the strain, C, the Young modulus. Given F equals to 20 Newton, L is equals to 4 meter, E equals to 0.24 millimeter, is equals to 2.4 times 10 raised to the power minus 4 meter. D equals to 2 millimeter, is equals to 2 times 10 raised to the power 3 meter. Stress is unknown, strain is unknown. Young modulus capital A is unknown. Solution. Stress is equals to force over area, which is equals to capital F over pi d squared over 4, which is equals to 4 capital F over pi d squared, which is equals to 4 times 20 all over pi times 2 times 10 raised to the power minus 3 squared, which is equal to 80 over pi times 4 times 10 raised to the power 6, which will give us 6.4 times 10 raised to the power 6 Newton per meter. Strain is equals to extension over length, which is equals to 2.4 times 10 raised to the power minus 4 all over 4, which is equals to 0.6 times 10 raised to the power minus 5. Young modulus is equals to stress over strain, which is equals to 6.4 times 10 raised to the power 6 all over 6 times 10 raised to the power minus 5. It will give us 1.07 times 10 raised to the power 11 Newton per meter squared. Example 8. Find the extension produced in a copper wire of length 2 meter and diameter 3 millimeter when a force of 30 Newton is applied. Young modulus for copper is equal to 1.1 times 10 raised to the power minus 11 Newton per meter squared. Giving L equals to 2 m, D equals to 3 millimeter, U is equals to 3 times 10 raised to the power minus 3 meter, F is equals to 30 Newton, E equals to 1.1 times 10 raised to the power minus 11 Newton per meter squared. E is unknown. Solution. E is equals to 4Fe all over 2D squared L. E is equals to capital E pi D squared L all over 4 capital F. Small e is equals to 2 times pi times, in bracket, 3 times 10 raised to the power minus 3 squared times 1.1 times 10 raised to the power 11 all over 4 times 30. Example 9. The total length of a string with a mass of 20 grams is hung from its ends is 14 cm, while its total length is 16 cm. When a mass of 30 grams is hung from the same end, calculate the unstretched length of the spring, assuming Hooke's law is obeyed. Given mass equal to 30 grams, initial mass equal to 20 grams, final length equals to 14. Solution. Fk. F is equal to Ke. Looking at the diagram, the first length when the body is not hanging anybody is L. When a body of 20 grams is hanged, the length is 14 cm. When a body of 30 grams is hanged, the length is 16 cm. So we asked to find the L. So we now say F is equal to Ke. Substituting the value, is now know that the first one is 20 for F. 20 times 10, which is 0.00 times 10 is 20, is equals to 14. That is the length minus L. This is our equation 1. Then 30 minus 20 for this weight is equals to 14 minus 16 minus 14. Therefore, 10 is equals to 2 for equation 2. Dividing equation 1 with equation 2, we have that 20 over 10 is equals to 14 minus L is over 2. Therefore, 140 minus 10L is equals to 40. Minus 10L is equals to 40 minus 140, which is equals to minus 100. L is equals to minus 10 over minus 100, which gives us 10 cm. Example 10. A vertical wire suspended from one end is stretched by attaching a weight of 20 Newton to the lower end. If the weight extends the wire by 1 millimeter, calculate the energy stored in the wire. Given weight equals to 20 Newton, extension E equals to 1 meter, K is known. Solution. Energy stored in the wire is equals to half Fe, which is equals to half times 20 times 1 times 10 raised to the power minus 3, which is equals to 0.01 gram. Gravitational potential is equals to Fe equals to 20 times 10 raised to the power minus 3, which is equals to 0.02 joules. Example 11. A spiral spring of spring balance is 25 cm long when 5 Newton hangs on it, and 30 cm long when the weight of 10 Newton hangs on it. What is the length of the spring if the weight of 30 Newton hangs on it, assuming Hooke's law is obeyed? Given length to be, we are given that the length is equal to 25